Hey, so in this lesson I want to introduce callables, which are invocable things basically, so you can invoke them using the function call operator. Of course, a function is an invocable thing, and we'll talk about function pointers, and in that way we can indirectly invoke functions. Callables are really handy in that you can have a function formal parameter, which will allow that function to then accept another callable thing, such as another function, indirectly with maybe a function pointer, or you can do a function object or a lambda, as we'll see in this lesson. Then we also have function objects, which are called functors, and those are classes that have the function call operator overloaded. Then in the standard namespace we have function objects, which are basically wrapper classes for callables as well. Those are really handy to use as parameters, so you can pass in either a function pointer or a function object into a function as an argument, for example. Then you also have lambda expressions, which are anonymous functions or nameless functions that you can sort of write in place, so you don't have to go and define a function with a special identifier and everything. Although, as I'll discuss, you can actually assign them a handle or an identifier, as you can do with a regular function. Typically, callables go beyond the scope of what you should be concerned with as a beginner, but because of the flexibility that it provides, and with their application with custom deleters for smart pointers, as we'll see in the next lesson, I've put together this lesson on callables for you. I'd like to mention some of the prerequisites for this lesson. You need to have an understanding of pointers and references, and also references to pointers, because in one of the lectures I'll be using a reference to a pointer, constructors and destructors, the function call operator and how to overload that, and then also templates. As a quick demonstration of where this is useful, we can have different functions such as add, multiply, or whatever you want to do. And then you have some functions such as modify elements, for example. This is going to take in an array. We pass in the size, and then we can pass in the standard function, or you can have as a formal parameter, you can have a function pointer or something like a functor as well. Or you can have a template. This modify elements can be a template. Then for every element within the array, I go and modify that element, so I can do the array parameter I pass in the index, and then with the second operand, for example, if you pass in addition, that second operand is going to be how much we want to add for every element. So we want to add 5 to every element, then we pass in as an argument 5 for the second operand. And then of course in the main function, eventually I'll go over everything that we do in this program, but for example, I invoke the modify elements right here and I pass in this lambda right here, or I can pass in the add function like that. As a pointer, I pass in the array size, which is defined up here, and then also the array, which is called victory points. I pass that in here. Just go and print stuff out. So I want to add 5 to every element within the victory points array. Those are 1, 3, and 5. The elements in the victory points array are initialized to those values. So if I build a run now, again they are initialized to 1, 3, and 5, and then we go and add 5 to every element, so we get 6, 8, and 10. Of course, we can do multiplication or whatever we want, so this lambda here is actually going to do multiplication, as we can see here. Take that and add that in here for an argument, and then build a run. And now we are doing multiplication on every one of those elements. The point of this is we can have some sort of generalized function that can take in a callable, that is a function or a functor or a lambda. And the definition of this modify elements or whatever function you have that takes in a callable does not rely or depend upon the definition of the callable that you pass in. So with that you can pass in, okay, I want to do addition, I want to do multiplication. In this case we are doing a binary operation, so that is something that you have to keep in mind. But even in the case when you are doing a unary operation where you pass in only one element, or in other words one argument for the callable, you can still do binary operations. If you use functors, so in this case we have this functor right here, we overload the function call operator, but it takes in 2 arguments, so this is a binary operation. But you can have one with a unary operation, and then the functor can have a state, a constructor, and a state, so a member variable, and in that way you can sort of manipulate that to perform a binary operation, even though the function that takes in a callable relies on a unary operation right in here. So if that is confusing right now, don't worry about it, we'll go through all of that within this lesson. And I will explain how to work with function pointers, so we can pass in such as the addition function, so we can pass that in, the different types of functors, functors that have a state and functors that do not have a state, and also these lambda functions right here, okay? So that is what we will look at in this lesson.